Hello, 2B3. Hope you all are keeping safe and not going too stir crazy out there. I just want to let you know that I miss you and I wish we could be doing this in person, but we can't, so here it goes. I've gotten a lot of questions and I knew they were coming up. I even told you they were going to come up of what actually is a logarithm. And strictly speaking, the definition of a logarithm is that it is the exponent. Now, what does that all mean? When we're talking about an equation that we've been looking at, like y equals b to the x, we've been having to do guess and check to figure out what x would be to make these things true, these sentences. But the logarithm actually refers to how do you figure out what that exponent is. Just a quick review of a couple of quick things. Inverse functions and operations, actually. Inverse operations. Remember that if you had something that was squared, the way to figure out what x is to undo the squaring. You do the inverse operation. So the inverse of squaring is square rooting. The inverse of cubing is cube rooting. You do that to both sides. And in both cases, that allows us to find out what x is. It goes all the way back to when you were first learning how to solve basic equations even. Right, x plus 2 equals 6. This is addition, so the inverse operation for addition is subtraction. So you'd subtract 2 from both sides. Notice it's the same thing. We're doing the same thing to both sides, and that's what we're going to end up getting to with logarithms. So we get x equals 4. Same thing with multiplication and division. 2x equals 12. This is multiplication, so the inverse operation for multiplication is division. Now, let's go back to y equals b to the x. This is an equation in exponential form. The variable is in the exponent position. If I wanted to translate this, that means rewrite it in an equivalent form, but put it into logarithmic form, the way I would write this is the logarithm, where the base is b, of y is x. So notice that the logarithm is the exponent, and that's what we were talking about before. So this is your logarithmic form. Now, where this comes into play and how we see this sometimes, remember we would have questions like 32 equals 2 to the x. Now, before we started learning about logarithms, the way we would do this is we'd say, okay, what's another way I can write 32? And 32 is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. And that's 1, 2, 3, 4, 5 2's. So 32 is 2 to the 5th. We would rewrite 32 as 2 to the 5th and get it equal to 2 to the x. We would then solve this by looking inside. The bases are the same, so the exponents must be the same, and know that x equals 5. Another way to do this is to use the logarithm question. So I can translate this equation into an equivalent statement using logarithm. So the log is how we say it, the logarithm base 2, that's the base, of 32, right? That's the base. The 32, the part in the parentheses, is called the argument, is equal to x, which is the exponent. This is asking the question, what exponent does 2 need to be raised to in order to get 32? That's the question that a logarithm asks. So we're going to be doing that and looking at a bunch of different problems relating to this. We're just going to do this kind of translation and then asking this question. Similar to the question, remember when we did absolute value, it actually asked the question, what is the distance from 0 on a number line of the number or expression inside the absolute value. So it's a shorthand way of asking a bigger question. And now we'll get into doing some actual problems.